Hello, everybody. This is Lorenzo Perella for Computer Science 1 TED Spring with Clark Wellman, and I'll be going over my quiz 3 today, which talks about the turtle module. We'll just be going over numbers 1 and 2, and while we could have also done number 3 extra credit, that was just optional. So let's get started. First one, we need to write a function that creates a four-colored square that is rotate at 45 degrees. And what it needs to look like is this right here, where it goes red, green, blue, magenta. So in order to do that, first we import the turtle and set the background turtle screen, and then that color of the screen will be dark green. Then we call it Rafael's Discovery, which is in reference to one of the, well, I think Raphael was more of a sculptor than a painter, but he was famous in the Renaissance era. Anyway, then we have for turtle here, Rafael, which illustrates the turtle for the module import and then for what the turtle is. The color of that turtle is red, but it doesn't really matter because we're doing that, but that's just a fun thing to do. Pen size is 1, and Raphael's speed is 1. Now, we don't need speed. That was more just to make sure that before I presented it, I knew how fast it was going and where I needed to fix code. Now, for the first part, you need to define my colored square, which is by Raphael, size, colors 1, 2, 3, and 4. And then describe that as turtle R draws a square with 4 colors at 45 degrees. Then, to get that 45 degrees, you go Raphael left 45. Then, you make a for loop for each of the colors that you're going to use. Continue that for the color C, then 4 of that size, and R left 90. Now, to prove that this works, first, what I'm going to do is put that, comment this to the side because we're going to go second. And to prove that it runs, as you can see, we have a 4-colored square with 4 pieces named Raphael's Discovery. Second, we are now going to make a series of squares just like this, but we're going to do it to look like this, a line of colored squares. First, we undo what we did earlier. And in order to get the line of squares, it's the same thing as before, but this time we have space and n. That space is going to be how much space we give in between each of those squares. And then it draws multiples. We have to describe it, illustrate another right of 45. The right here is important because then it turns the turtle back to where it needs to go. And then for I in range of n, you use the previous function of my colored square. Then from that, you put right 45. This ensures that every single time it turns, but then once it turns 45, it's going to go pen up, which means it's not going to draw a line, then forward, the size of whatever you put in, plus the space between each square. And then it's going to put the pen down. And it's going to do this n amount of times, which in this case is going to be 5. Now to prove that we can do this, first we need to comment this part out. We don't want to show what we already did with the number 1. We run, Oh, sorry. Okay, so my bad. We have to actually have that in there in order for it to work. My bad. So first we have our first square as such. Then it goes around to create those squares again. It'll take a space, go. Now if I extend this out, you can see all of the squares. But in the end, you see how it does, and it spaces everything out. The turtle's over here, and you can't see it. But in the end, this is how you get it. And I could, and then that's pretty much it. Thank you for tuning in. This is Lorenzo. It's quiz 3. Have a wonderful evening.